Good morning. We will start the lesson. Last time I taught you how to create reference planes. So we discussed about several techniques of creating planes. Today we will look at the other methods. So I'm going to start with the reference point method. So why we actually need points when we want to create, basically when we want to create axis, or when we want to create a coordinate system, normally we need reference points in SolidWorks. So we will look at how to create these points taking this example. So I will open a part file. I will open chapter 6. We can open any part file available. Say I will just open this one. So on the reference geometry, we have discussed plane methods. We will discuss axis, coordinate system, and points today. So we will start with the point tool here. If you look at these are like 3D tools which are coming to the design tree. Now if you look at the sketch tools also, you have the point here. This is a 2D point. So when if you want to create points in 2D sketches, these can be used. So for an example, if I want to create a point in this plane, say we go to sketch mode, and we can use this 2D point. So 2D point was placed. Then if you want, you can apply smart dimensions for this. So from here to here, this value, and from here to there, something like this. So you can define it as a fully defined sketch. Now it's fully defined. So these are actually 2D points. So when I exit, it will be look like this, and it's a 2D sketch. Now if you want, you can do this way, but there are better methods than this available under reference geometry. This is called point method. So when I click on this, we have several methods of creating a point. Now first one is called arc center. That is, in this example you can find an arc here. So if you want to locate the center of the arc and get a point, just click on this arc here. Just get the method, click on the arc here, arc here, not the surface, this edge. It will create you the point in the middle of the arc. So if I do it again, you need to just select the method here and click on the arc edge. It will create the point in the middle. So this will helps me to create an axis going through this. So if you just look at this, this is not a sketch. This is like a feature. So you have this point as a feature in the design tree. Now it will be hidden automatically. So if you want to unhide it, it's now so now it's showing, but you may not see that those things clearly unless you tick this button. So there's a button called viewpoints. Sometimes this is disabled, so you need to enable this button, otherwise you may not see the points you have created in the screen. So we will just hide it. Then we have several other methods. One is called center of face. So if you want to get a point right at the middle of the face here, just use this method and click on the face. You will get the point in the center of the face. Okay. Now if you select this as the face, it's getting this whole rectangle and take the center here. You can see how it works. Center here. Then we have intersection. So if two lines are intersecting or two edges are intersecting, if you want to get a point in this intersection, can be done from this tool intersection. Just select this edge, it will create the intersected point. Then we have projection method. Projection method is if you already have some points here and if you want to project it to here, this will be useful. So I will show you how it works later. So we will look at what is meant by on point. Now on point is we can use this 2D created point and make it a 3D. Now if you just select this on point method and click on this point, this is a 2D point I created, this one. So I can have a overlapping 3D point on top of that. So this will be my parent, this is the child. So this is actually helps us to make a 2D point a 3D point. Now we were left with this one, projection method. So what we mean by projection is if you have a 2D point on a sketch and if you want to project it onto another plane, that can be done. So I will show you how it works by creating another plane, this tool, projection. I will create a plane parallel to this. One example, this one. Now I will create a point on top of this 2D project, 2D plane here. Just I created the plane point here. Now, sorry. We will take this a little bit up here. Now, if you want to create a point or somewhere here, it's not possible because this is not a plane. So what we can do is we can select this as the working plane and sketch on that. We create a 2D point here, right in the middle. Now this 2D point is created on top of the plane here. Now this is a 2D point. So this 2D point can be used to project onto this face. So I will use this tool called point and use this projection tool here and select this 2D point and this face. So what happens here is I selected this as the parent and this is the reference plane we are going to project. So we selected this face, press OK. You will see the 3D point appears here. So I can use this 3D point for another one. So because you have to remember that we cannot do anything in these curved places. So you have to do whatever the things you want in a plane like this. And I projected that point to here using a 3D tool. So we use this projection method to get this on onto this one. So you can try these methods and any questions let me know. Try all these methods and see whether you have questions.
taking a separate plane, part 1 selection cut.
If you don't have questions, I will move to the next area. So remember these techniques when you want to create a complex design. These may be useful. So I created several points in this sketch, in this model. Now we will look at how to create axes on in these kind of models. So why we need axis? Basically, we need to when we want to create patterns, especially when we want to create patterns like circular patterns, we need this axis tool. So I will look at this tool now, axis. So first one is it's a easy one. It's called one line edge axis. So you need to just select an existing edge, and you can make it an axis from this tool. So I just selected this edge, and that's okay. Now on top of this edge, I created the axis. So this axis is virtually unlimited. This is going to the infinity. So if whatever the area I'm going to design, this axis can be used. Then we have two planes. So this is kind of a very important method how to create an axis using two planes. Now if you take a empty file, you have these planes, these original planes coming from the software. So if you want, you can use these two planes to create an axis going through this. So if I just select these two planes and run the axis command, automatically this is selected, and you can see an axis is created uh, in the intersection of these two planes. So this axis may be useful when I want to create some rotating motion. So if you want to create a gear wheel, rotating gear wheel, this axis can be very useful. So when you do complex designs in SolidWorks, these may be useful in the future. So if I come back to this example, now I have a plane here which was created by me, and another plane, say something like this one. So if I want to create an axis going through these two planes here, just select these two planes and come here and select the axis. Automatically this is selected, and you can see an axis is being created. So this axis can be used to create a rotary motion or a circular pattern. A lot of things can be done from this axis. Then we have 2 points vertices. Now if you want to create an axis something like this at an angle, so we can use this 2 point method. 2 point vertices. The first point here, second point here, and axis is created. So it's very useful. So I just selected this vertex and another vertex, these two vertices, and then axis is created. So then another one is available. It's called cylindrical conical faces. So this is a cylindrical face. If I want, I can select the cylindrical face, and quickly, we can create an axis going through this cylindrical face. Or else I can use this cylindrical face, same result, and axis is created going through the cylindrical face. So you can select this face or else this inside face. same results because this shares the same center. So, for example, you can use this axis for a circular pattern. Next, we are going to discuss these tools. So, for the circular pattern tool, we need a axis. So, pattern axis is needed. So that's why we are learning these things at the moment. So this pattern axis is needed for these kind of circular tools. So remember how to create these axes. Sometimes if this is switch off, you may not see the axes you have created. So these axes are disabled, hidden if this is switch off. So there are some tools available here under this eye. If you disable this, you won't see the axes you created. If you disable the planes or enable the planes, you can see how it works. These may not be visible. So any questions about the one edge? One edge is this one. Just select the edge, two planes, select two planes and create an axis going through those planes. Then two points vertices. Just select this point and this point, or you can select these 2D points even. Then cylindrical conical faces. This cylindrical face, this conical, or these faces can be selected. And the last one is very interesting. This is called point and face plane. So you can see in the graphics here in the picture, we can create an axis going through a point and perpendicular to a face or a plane. For an example, we can use this point and this plane, and you can see I selected this point and the face here, and I can generate an axis perpendicular to this face. So this is really useful when I want to create a pattern somewhere here. If I want to create circular patterns here, this axis may be useful. This is going infinitely up and down. So this is how we created that. So I will do it again. So you have to have 2D or a 3D point placed on the plane. And we will run this axis tool here, last method. This face and this point. Quickly we can create an axis. You can try these 5 methods, and any questions, let me know if you have any questions. So we will start coordinate system method. So why we need coordinate system? Basically, if you want to create a pattern, or if you want to define the local origin, this may be useful, especially in CNC operations. These reference coordinate systems may be useful. So I will look at how to create a coordinate system now. Now, when I use this tool, I will find several axes. So, if I want to create a coordinate system here, X, Y, Z, so you need to select these references. Now, first I need to give origin, local origin. So, this origin can be selected from the vertex C. So, when I select this vertex as the origin, if you want, you can press OK. Now it will create the coordinate system in this manner, X, Y, Z. So, so if you want to change this X and Y and Z directions, you need to give other inputs. So I will go to edit again, and I want to change my X-axis direction. Say we can select this as the X-axis direction. So you can see X is in this way. Now this will follow the left-hand rule. So I hope everyone knows about the right hand rule. So you need to use your 3 fingers and get the directions X, Y, Z. So you need to give X, and if you want to give Y in this axis, you just select this edge. Now the Y is in this one, X is in this way, Y is in the other. So if you want, you can change the direction of Y. So according to X and Y, if you use the right hand rule, Z will be going downwards. So you don't need to give the third one. So I will do it for another point. So if I want to create an axis here, coordinate system here, just select this method and click this point. Coordinate system created, x here, y here, z here. So x, if you want to change x to this direction, just click on this one and click on this edge. X is in this edge, and if you want, you can cover it. This x is in this direction. Y is in this direction. If you want, you can put it to this. So just click on this. Y is here, and z will be automatically taken this direction. So this is how we create coordinate system in SolidWorks. Now these coordinate systems may be used in these kind of pattern methods. So I may not do all these things since we don't have time in the syllabus. So we will look at the basics only in the class. So if you try to use this table driven pattern method, they will ask you the coordinate system you are using. So this coordinate system is useful when you want to create a pattern using a table. So this will be your origin, 0, 0 location. The other points can be defined one by one. So for these kind of techniques, we need this coordinate system method. So that's why I told you about this tool. So any questions about this plane, axis, coordinate and points? These two are under assembly, so we can't deal with now. So this is, any questions about plane, axis, coordinates and points? I will look at this area now. I may go somewhat fast, so you need to catch up with me. So I'm going to look at some advanced box-based methods. We will open the part file like this and show you how this works. So I will try to open a part file, chapter 6. I'm going to open this part file in chapter 6, figure 636. So we are going to look at some advanced methods of doing some box bases. So now if I want to generate something like this kind of a shape, I can't do sketches on this curve. This is not a plane. So if I try to click on this, you can't find the sketch tools available. But if you click here, I am getting the sketch tool, but it won't come in here. It won't be coming here. So no sketch tool. So if you want to do some sketching here, we can't do it. We have to do it in a separate plane. So that's why what they have done. They have created the plane, offset plane, and made a sketch there. But at the end, I want something like this to be generated. So that's why we created the sketch in another plane, and I want the sketch to be extruded from this surface. So how can we do that in SolidWorks? So I will extrude this. So if you just click on this one, extrusion happens from here. That is not what I want. So if you want, you can reverse it. I don't need this to be starting from here. So I want it to be started from somewhere else. It's called, I want to change the starting method, starting place. From tool I have to change. So I can select this as the starting surface is this one. So when I select this as the starting surface, extrusion happens from here. It's a blind value. This way we can change. So if I press OK right now, you can see the sketch has started the extrusion from this surface, but actually the sketch has been done on this plane, but no one can see it. So this is the usefulness of this starting methods. So I will do it again. So basically, first understand that you cannot do anything here because this is not a flat face. This is a curve. So sketches cannot be done. So I did a sketch parallel to another face, created a plane. So everyone should know how to create a plane here, offset plane. And on top of this offset plane, I created the sketch. Then I went here, extrude best place, selected the sketch. But it's starting from here, so starting from the sketch plane. So I have to change it to surface, face, and plane, and click on this. And end conditions, I cannot use the other ones because there is no other points or vertices or surfaces here in this side. So just say this as the blind value. Just okay, this is the result. And now without using the surface face plane, if I try to use this other method called vertex, what happens? Say I can select this as the vertex. So the sketch happened from here. So if you just increase the blind value, you can see sketch starts from here. 3D model starts from here. Luckily, we have the merging results, merge material. We can merge the materials, so there is no problem with the weights. And you can see the end face is flat. But if you use this as the method, end face is curve, taking this shape. End face is taking this shape. But if you select the vertex here, end face is flat, similar to this. So when I press OK here, now I am getting a flat end face. So you have different ways of doing this in SolidWorks. So you need to know these right methods, right tools to generate the correct 3D model. So I hope you understood difference between surface and vertex. Surface will take the surface end conditions this way, curve, offsetted the curve here. Vertex is, if you select this vertex, it starts from here. If you want, you can change the direction this side and get it to the other side, no problem. Okay. So there are a lot of ways of getting the same outcome. Any questions about these two methods, surface, face, plane, vertex?
So can you repeat that vertex part again, please?
Vertex?
Yes, vertex part.
Vertex, you need to just select this vertex or this vertex. So if you select this vertex, software automatically draws a line here, and it will be a flat one, and your end face is also flat. But if you select the surface, your end face is a curve, because the starting face is a curve, so it will get the offsetted curve here. So it depends on the outcome you need. If you want to get a flat surface at the end, this method is not good. You have to use the vertex. Since we are merging the results, there is no problem. If I unmerge the result, what happens here is there will be material intersecting inside. So if you just look at the hidden lines or the wireframe, you can see the material intersect. So your weights calculations will be different. So you have to know those things. And you can see there is no boundary line here. I can't see a boundary here because this is going inside. So this is happening when I unmerge the results. So there is no parting line here. You can see when I merge the result, what will happen? When I merge it, you can clearly see a part in line. So little things, but it makes a model a big change. So weights will be changed. So I hope you understood what is this tool. Last week also I discussed about this tool. This is really important tool in SolidWorks. And we have the last method here called offset method. What do you mean by offset? Now, if I want, I can have an offset and start this sketch. Now, sometimes we may need to start something like this. So I have an offset from here to here 20 millimeters. And if you want, you can change the end conditions now. End conditions can be up to next. So this is also possible. Now I started my 3D model at an offset 20 millimeters, and I ended up with next surface. Or else you can end up with up to surface and something like this. Select this surface. Lot of things can be done. So, and it's going until here. Or else you can select this one, offset from surface, and select this face as the offset. You can see how it works now. Uh, so what is the meaning of this one? I started my starting point offset 20 millimeters from here to here 20 millimeters. Then I ended here from this surface 10 millimeters this side. So if you change this one, it won't generate actually. Reverse this way. So I hope you understood what I am telling here. Started from 20 millimeters away, this offset, then ended here 10 millimeters away from this surface. Offset from surface. This is the end condition. Okay, so you have a lot of end conditions. One is blind value. Simple one is the blind value. Then we have through wall. It's going through wall. Then we have up to next. Automatically it will find up to next. Then we have up to vertex. We can select this vertex up to vertex. Then we have up to surface. That is, if you want, you can select this as the surface. Or else you can select this as the surface. Anyway, this is merging. Then we have up to body. This is the body. So this is a single entity, it's called a body. So up to body tool is also working. Up to bodies, it's a single part, single feature. It's separately there, so you can select the sketch to be extruded up to this body. Then we have mid plane, that is we can extrude both sides symmetrically. You can see how the mid plane works. Then we have offset from surface. Select this surface, and I gave 20 millimeters away from this. If you want, you can reverse the offset here. Then this side is 20 millimeters. So I hope you understood the different outcomes. So this is my outcome this time. So just play with these tools and see how it works. Really important. So you can change the starting methods in 4 ways, ending methods in around in 8 ways. So better you know all these things, then you can nicely generate your 3D model. This is another example of up to body. You can have a sketch here, and this is separately drawn, that is they are not intersecting with each other. So this model and this model are not connected or intersected. So you can have a sketch going from here to there. So that's what we have done here. So you can start the sketch from here and up to this body. You can quickly generate the 3D extrusion. So this is what is meant by up to body. We will look at the cutting tool also in a little depth now. So we will start these advanced cutting methods. Similar to the boss extrusion, we will look at cut extrusions. Uh, I will open this file and explain you how it works. I will open figure 669. So same problem here also. We can't do sketches here. We have created a parallel plane, and on top of the parallel plane, we have created this sketch. Now, if I try to cut it, I will use these cut tools now. Extrude cut. We can start from this. So if I just give a blind cut like this way, we can blindly cut it. So the cutting happens this way. So material is removed and the bottom surface is a flat surface because I started from this flat sketch. So I just gave a blind value. This area is actually not. This is really not very good way of cutting, because if something is here, that will be also cut. This is like unnecessary cutting happen here. So if you want, you can change the way the cutting happens. Now, if you want, you can use this surface place plane tool and start this as the starting plane. So cutting starts from there. But you can see at the end, the end face is taking this same shape. So if you just reduce the value here, like this, end face is also a curve, not a flat surface. So you can see how it works. End face is also a curve. So that may be a weakness. So if I want to get a flat surface, the early method will be more suitable. So early method was like this. Early method was this way. It's a blind cut. But the problem here is, if something was there, another 3D model is here, you cannot have this kind of a cut. So it will be also cut. So end face is flat. There's no problem with the end face. So if you just select surface face plane and select this as the face, your end surface will be a curve. So which is not my requirement. I hope you understood. And if you select this as the vertex, as the starting, if I just select this one, this will be my cut. So the vertex method is really not good here. Cutting is not happening from the top here. So because the vertices are not, they are aligned correctly. So if I just select this vertex, cutting happens, but I cannot see any cut here. So vertex method is not good here. Offset method is also not really important. So if you want, you can get something like this also, starting from here. So it can be done without cutting in this area. We can just cut from here, starting from here, and give some line value like this and do it. So that's also a possibility. So press OK. You get a flat surface, but there will be less air cutting here. So less air cutting compared to the other method. This area is preserved. So if I just use this one, so starting from here, so that may be not good. We can offset and start. Then only this area is cut unnecessary. So I hope you understood. So we will look at this method, surface face plane, and select this surface. This is the perfect way of doing this. But the problem here is, the bottom is not a flat surface. Bottom takes this shape because I use the blind value. Since I use the blind value always offset the starting face shape. It always offset the starting face shape. So I have to have a flat surface here at the end. So we need to use another way of getting it. So we can use this one. The easiest one will be this one, offset from surface. Luckily I have a flat bottom. So you can select that flat bottom as the offset value. So we'll increase this, decrease this, and see how it works. So I selected the flat bottom surface, and now I offsetted 5 millimeters from it. If I reverse it, it is going the other way. So I don't need that to happen. Just reverse this way and get the flat surface. This is the perfect way of cutting this. So you can try this one and see any questions, let me know. 100% perfect. We don't air cut here. Nothing is cut on this area, in this area, and the bottom is also flat. Starting from a curve, ended up with a flat surface. Starting from a curve, ended up with a flat surface. So just do it and see any questions. Let me know. Now we will look at a tutorial from these things. So I have almost completed chapter 6. So we have Revolve Cut and this cut only. We will look at this one also and go to the tutorial. So we will look at how this cutting happens. So I will just take some part files and show you. Now if I take this part file called 675, if I want to cut this object, we will use this Extrude Cut tool. Select the sketch here, and there's a cutting happens. Now if I want, I can have a draft for the cut. Draft means I can have an angle. So if I just increase this angle, you can see how the cutting happens. So the drafting can be inside or outside. So I can change this outward. Now the cut happens this way. So you need to have a small draft when you create molds, especially when you create molds. You need to have a small draft in your design. So this is the outcome with the draft. Here I have given a big angle. Normally we will give less than 5 degrees. So in every plastic designs you may have seen this kind of small drafts in the design to accommodate the molding. So there's a small angle in this drawing. Now what happens if I do a through-hole cut? So if I just do a through-hole cut, what happens here is this will be separated into two bodies. Now this is a single body. This will be separated into two bodies. So when I press OK now, this message appears. The single body became two bodies. So if you want to keep these two bodies, just press OK. Now there are two bodies in this file. In this part, we have two bodies. So part is 675. We have two bodies in the part. So if you do extrusion from here to here, we can apply that two body method. So if I just do extrusion here, okay, and here there's a method called up to body. So automatically, not automatically, we have to select the next body. So there are two bodies here, and now earlier it was a single body. Now I made them two bodies from the extrusion cut extrusion. So we will delete this and delete. I will delete this also. So this was the single body. So I applied the cut tool. Since I applied the through all cut, this happened. Now if I want, I can select a single body and keep this one on. So if I select this one, this will be removed. So I have only one body at the moment. So if I want, I can select the other one and remove this. So these options are available in SolidWorks. So this happens when you do a through all cut, not for a blind cut like this. So blind cut will not separate this into two bodies. If you have a blind cut, something like this, now it will become two bodies. So I hope you understood the concept here. Now it won't have two bodies because there is a little bit material here left. Okay. Now it will be two bodies. If I select both bodies, both will be kept. So you can see how it works. Just do it and see any questions. Let me know. Now let's look at the Revolve Cut. So we have done Revolve extrusion. Now we will look at how to cut material from Revolve. So I will draw this sketch on this example. So if I want to draw something like this, it's not difficult. You need to just draw an axis and a sketch. So I will just click on this and go to sketching, and we will draw the shape. So if I want, I can draw a center line. Say I have used the origin. Better you make it perpendicular like this, and I will just draw a center line, and I will draw a shape here this way. Now I didn't close this. I didn't close the sketch. We will see how what happens now. Without closing, I just do a center line and just a normal line, and I will cut it now using Revolve Cut. This message will appear. Sketch is currently open. So since this is open, and this warning will come. Would you like the sketch to be automatically closed? If I press yes, automatically he will close this for me. And I need not 360 degrees, 180 degrees this side. That's okay. So this happens. Cutting happens. So if I just go and check my sketch now, he has drawn a line for me. So I don't need to draw a line. Automatically he has done it for me. If you want, you can draw a close sketch and do this work. So I will do it again and show you how it works. So without the center line, can we do? So without the center line, if I try to do it, what happens? I will just draw another shape here. Okay. Uh, I have problems. Open. Yes. So I have a problem here. So open sketch. I have it. Sketch is open. So you can see how I will delete this and I'll try to do it again. Now there's no center line. It's open. Then what happens when I run the revolve? It won't work. It will ask me the revolution axis. So I don't have an axis to show. So that's what happens when we don't draw center line. Or you have to have at least a close sketch. So when you have the center line, there's no problem. Software will automatically select it as the axis center and he will give you this warning. He will close it for you and he will create the cut. So that's how it works. So better you have a closed loop and a center line, or else at least a center line and an open loop. Then it will work. Now we will look at how to do this model. Now if I just look at this straight away, can we start from front view? So if I try to start from this front view, I have problems because this has a cylindrical shape here. So the cylindrical shape information is given in the plan view. So you can't just draw this front view and do this because this has Revolve tool here and extrusion tool here. So we have two tools mixed together, Revolve and the extrusion both. So that if you try to draw everything here and try to extrude, you can't get the cylindrical shape. So when you get complex designs like this, now gradually I'm going to do some uh, complex designs. So you will not be able to do it in one sketch. So you need to have several sketches and get this shape done. So here if I try to use this front, you cannot draw the cylinder and start the work because I don't know the end. So we have to have this shape first drawn and draw the cylinders in a plane and extrude to the surface, because this is a curve, you cannot draw here anything. So everything what we have learned here is needed now. So we have to draw only the areas we can extrude first. So we can extrude this area only without the cylinders. So if you just look at the steps given, we have to extract the information and draw only this shape, only this shape, and extrude this and get this kind of a shape. And but if you look at the outcome is cut again. So you have to draw a sketch here again on top of this plane, on top of the surface, and cut this unnecessary material, and get this shape. After you get this shape, we can sketch a plane and draw the cylindrical circular shape and extrude this. Then if you want, you can apply a Revolve Cut at once or two extrude cuts, big one and another one separately, and we can drill these holes at the end. So that's how it works, this tutorial. So I will start the tutorial and show you how it works, and you also can do it. So we have to extract this information. So when you get an assignment or a project, you need to understand what to start, what to draw first. Normally we don't give these steps in the assignment or a tutorial or an exam. So you need to know how to work on this. So I will have everything in one slide. So we will start now. So I have to extract the information from here. So the origin is not in the arc centers are not here. Arc centers are somewhat away from here, 39. So we have to draw this shape first. So I will put this here and start this. So this may be front plane, select. Then if you want, I will draw the center lines. No, better you draw them. Then here, if I look at this sketch, center origin may be here, but the arc centers are somewhat away. So if you want, you can have the origin here. In this one, origin is here. So I will take it as it is. We will use these easy tools like corner rectangles and try to get the rectangle shape first. So we at the bottom we have a rectangle here. So I will make it symmetric. Symmetric. Then this value is 300. This value is 25. So 300 is taken from this one, 250. This radius is 25, so 250 plus 25 is 275. This side also 25. 300 is coming, so 300 is there. Then 25 is the height. Height is given here also. 39 is, there's a point here, somewhere here, 39. So if you want, you can locate a point also. So if I want, I can use this 2D point and locate a point somewhere here. And that point is 39 away from the bottom here. So from here to here, it's 39. So why I need a point is to draw this arc shape. So 39, and you have two arcs now, 105 and 80. So if you want, you can draw circles. That's up to you, and trim the circles. Or else you can draw the arcs. So if I just remind about circles, this is one circle, this is another one, and you can have smart dimensions for these circles. This is radius is 105, so diameter is 210. This one is radius is 80, diameter is 106. Then we can trim. I don't need this. So this is the shape I need. So if we just look at this diagram, I got the shape now. 325, 39. All these are given. But the sketch is somewhat blue color, so you need to fully define the sketch. So if I want, I will delete these things. And put the radius here. Still the sketch is blue. So I will try to make them symmetric. Sometimes it may not be there. So click on this, make it symmetric. Then still the lines are blue in my sketch, so I will try to apply this fully defined tool. Select entity, say this one, and still underdefined. So this one, so I will say this one is horizontal, co-linear to this one. Now it's fully defined. So I got the fully defined sketch. Now if I look at my diagrams, what is the extrusion length? If I just look at this one, this is the diameter of 150. So I have to extrude this by 150. So maximum value is 150 diameter. So both sides 75, 75, 150. So I have to extrude this by 150. Better you do it both sides. Then your drawing is 3D symmetry. 150 both sides. 75, 75 both sides, 150 total. So I hope you got this shape. Take this shape, then we will continue. This is chapter 6, tutorial 3. You can try the other, you can try up to here, then I will continue from here. So I hope everyone can do this. This is not a difficult sketch. Now the next challenge is to cut this unnecessary material. So I have to cut this unnecessary material, these areas. So we need to do this sketch. So we cannot draw anything here. So better we create a plane and do this. So if you want, you can create a plane. Later also I have to create a plane to get this cylindrical shape. So better you create a plane 150 away from this one and use this plane to get this sketch as well as this sketch. Otherwise you have to create two planes. Somebody can create a plane touching this one and get this cut. But again he has to create up another plane 150 and do it. So you don't need to repeat the plane creations. Better you do it in a single plane. So I will create a 150 offset plane and draw the sketch and cut it. So I will first do what? Create a offset plane from the bottom 150. So we will do it now. From here 150. Why I did this one is because I need to create a cylinder later also. So we can do it from a single plane rather than creating two planes. So we will make it like this. So if it is turning the other way, you can again click on this. Then click on again, flip it like this. So if you want, you can make it hidden lines visible like this and make it a clear sketch. So now I have I will draw center lines. So you have to draw another face sketch. So we cannot rely on the all center lines. All center lines are not shown. So you have to draw it again. Now talking about this sketch, I have lines and I have arcs. Here I have arcs. Here I have lines. So but if you think carefully, I have to have this shape somehow. So better you draw circles and do this work. So if you just look at this one, 75, is there a circle is here, another circle is here, another circle is here. So I have a radius 150, diameter 150, diameter 50 circles. So I will draw circles. That will be easy for me. This is 150 circle. Later we will dimension them, and there will be another circle of 50. So this will be 150 in diameter. This will be 15 diameter. So the circle 50, there are two circles, and those are 250 meters, 250 millimeters apart. So I can have a mirror of this circle about this center, and these two circles are 250 away. So I'm trying to use minimum number of tools and try to get this, and this should be symmetrical. So we can select the center of the circle, center line here, center of the circle here, and make it symmetrical. Then we need to have these lines. So I have circles, we can just trim them later and draw circles now, draw lines now. So we use the line tool here and get the tangent option from here to here. Tangent. So you can see the tangent symbol appears. So I drew one line tangent. So the tangent symbol appears. If the tangent symbol doesn't appear, you have to apply it manually. Now everywhere I have to draw 4 lines, but it's easier if I use the mirror tool here. So mirror tool, I'm going to mirror this line about this center. So you got this. Then you will mirror again these 2 lines. Why I'm doing all these things? To avoid these sketches, manual sketches. So I got this shape. So I drew a big circle and a small circle only. Then I got the mirror here, symmetric. Then only one line drawn, mirror here, both lines mirror this side I took. Then I trim. So this may be the easiest way. You may have other ways also of doing this. I find this is easy. So I drew this sketch now on this plane. It's a fully defined sketch. Okay, now we have to cut it. So we will apply the cut tools, Extrude Cut. I have to reverse the direction. If I want, I can cut blindly because there is no material here, there is no problem. Otherwise, we have to use the tools we have discussed here. If I want to do it perfectly, you can use the surface tools and other things. So for the time being, we can use this one. Our through-wall cut is okay because this is simple. So I have to press OK. So now what happens here is I got the cut in a wrong direction. So I remove the inside material. So I have to remove outside material. So how can I do it? In the cut tool, there is a tool called flip side to cut. So if you just click this button, you can see this as an arrow coming here. Now I have to remove this area. So if I just untick this, I am removing the inside area. So I didn't teach this one when I teach the tool earlier. So there's a tool available to select the cut-in area. So I have to remove the outside material. Just select that one and remove the outside material. So this is the shape I am getting. So I hope you understood. So if I reverse my operations, you can always reverse this. This was the starting. Then I created a plane and I cut this way. So try to get this shape. Any questions, let me know. We will discuss. I hope you are following me. Then we have to draw a cylinder like this and get the extrusion going down. So we will do that in a while. This is for the cylinder. Any questions, let me know. So without drawing this 4 times, I just drew a one line and use the mirror tool here and got the mirror this side and again use the mirror tool for these two lines and got it this side. That's what I did. Then you can obtain that shape. So I didn't save it, so I will quickly do it again. This is 150 both sides. So remember that SolidWorks doesn't save the sketches automatically, so you have to always save them. I will quickly do it again, so I have to bring this. Okay, now this is, take both sides 150 mid plane. Otherwise, you don't have that facility to draw the cylinders and the other cuts. Difficult. So you get a mid plane extrusion both sides. Then I created a plane again. I repeat this process. 150 away from here. This plane is selected. Get it to this side. If I want, I can apply, get lines on, just draw center lines. Another center line. I drew a circle here. Another circle somewhere here. For 150, 50. Then got the mirror. Between them, it's 250. Done. Then use the line tool here. Take it from somewhere here. Don't take it from the quadrant. Take it from a circumference and get the tangent correctly. Otherwise, you get it quadrant. Then see whether the tangent symbol appears. Then mirror this one above this line. Done. Repeat mirror. These two about this. Okay. Then we will trim it. If you perfectly do these things, there will be no holes in these areas. So you have to make sure there are no holes in the drawing. Then we will apply cut. Direction change. This is a through cut. Cutting direction is outside. Okay. This is how it works. Then we have to draw the other circular shape. So that cylinder is also 150 diameter. We will draw it on the plane we created. This plane we can use, and I will make it perpendicular and make this visible if you want. And this one now 150.
Excuse me, sir. Can you repeat the cutting part? How did you get to?
Yeah, wait. Now I drew the 150 circle. Then I can extrude it up to next. If the up to next is not working, you can select up to circle. So this is how it works. So cutting tool, it's not difficult. You just select the cutting direction from this method. So it's cutting outside now. If you want, you can cut inside or outside. Here my requirement is to cut the outside material. So this will be the result. So that's why I created a plane here. Then I can use single plane and do this circle sketch, and the cutting sketch also you can be used from this single plane. So this plane is parent to these two operations. So this is just a normal cylindrical shape, 150. And if you look at this one, this is a sketch I drew and I explained now. So I hope you understood how this works. So basic idea is you can't draw everything in one sketch. Early tutorials we used only extrusion method. Now we are using extrusion and revolve both, and we are cutting material, so we can't draw everything in one sketch. So you have to use several sketches and make them fully defined and use correct 3D operations. So I came up to here, then I have to cut this inside also. So if you look at the inside here, it's 75 and 100. So you have to have two cuts here, 20 depth, and here up to here. So this cut is 100 diameter. So you complete up to this point, then I will complete up to this point. Then we will discuss the other things. Okay, we will cut inside now. So I have to get this shape. One way is we can apply 2 extrusion cuts, or else they have used the Revolve Cut. So if you want to apply Revolve Cut, it's a one operation. I will first show you how to apply Extrusion Cut and do this. So we need to have 2 cuts here. If I use extrusion, the diameters are given here, 175. So 100 diameter is 20 depth into millimeter 20 millimeter in depth. So this should be cut. You can draw a circle here. Circle is 100 millimeters in diameter, and the cut is now 20 line cut. So this can be done. So I have done a cut extrusion. So 20 millimeters, 100 diameter. Next one is 75 millimeters. It's going through wall. So I can select this surface and again draw a sketch. So I'm actually taking more time. This is 75. And this is a through wall cut. So we can have up to next even, up to next, cut it like this. So this is my result from the cutting methods, from the cuts. Or else we will roll back the model. We can always go back and roll back these things like this. Or else there are other tools like we can hide these things. So if you try to hide this extrusion, what happens? The entire part will be hidden. It's like I'm trying to hide my body, part of a body. It cannot be do that. You cannot do that. They say if someone wants to hide yourself, if someone wants to kidnap you, the person has to kidnap your entire body, not a part of your body. So it's something like that. So if I want to hide it, hide this extrusion only, it cannot be done in SolidWorks because it's a part of this feature is a part of this main body. So if you want to hide this only this extrusion, there's another tool called suppress. So you can suppress this without deleting. If you delete it, it cannot be reversed. So if you suppress it, that part, that feature only will be suppressed. So that feature and the child also got suppressed. So you can always unsuppress these things. This is not about deleting, this is about just hiding temporarily. So you can't hide it like this because it's a part of the main body. So you cannot do that way. So hiding operation is not going to work for this one. So you can always suppress this rather than deleting it, or else you can take the model back to this position with, and do your things again. So we will do look at these operations later in detail. Now what I'm going to do is I'm going to apply a Revolve Cut. So to apply the Revolve Cut, we have to do this kind of a sketch. So we have to draw the sketch like this and apply a Revolve Cut. So I'm showing both operations, cut extrusions and Revolve Cut both. So to apply Revolve Cut, we have to use the plane, something like front plane. So I will make it perpendicular this way. And if you want, you can make hidden lines on and draw your profile. So you will draw that. Now I have to draw this shape. So 75, 100, 20. So we will do that. So you can see they have taken the sketch outside the model, make sure that the cutting happens here perfect. Or else you can have the sketch like this also without getting it outside. You can nicely stop it here. Then you need to do some more work. That's why they have just drawn a rectangle shape here. So if you want to do a perfect cut without coming outside, we can do it. So I will show you a method of doing that. So we have to draw the shapes. Draw this shape. I am going to draw this perfect shape now. So how can I draw this here? So we can use these existing lines to do that. Now there's a tool called Convert Entities. So I'm going to use this tool to convert these 3D boundaries to 2D sketches. So you select the, now I am in the middle plane at the moment. At the moment I am in this middle plane. I am sketching on the middle plane. So we will use this Convert Entity tool and convert these boundaries to a line. So now it was converted to a line, and this also converted to a line. So if you just look at this and press OK, you can see those 3D boundaries have been converted to lines. So those lines I can use it now for my drawing easy. So I will draw a center line. And a line like this. So you can see the things I am drawing. So I didn't draw this one because I don't know the center points. I don't know the arc radius. If I try to draw the perfect arc, I have to do a lot of calculations and do it. So I am not wasting my time. I just use this Convert Entity tool and convert this 3D boundary to a 2D sketch. That's what I did. Then I trim this area. Unnecessary things. This is unnecessary. This is unnecessary. Then this should be dimension. Sorry. So this is also unnecessary. You can see I am generating my sketch. So this is also unnecessary. So if I look at my dimensions, this is 50. This is 37.5. This is 20. So this line is 50. This is 20. $37.5. $37.5. And from here to here, I don't need that value. I don't need this 130 because I stopped exactly on this curve. Now I did my sketch. Then we can apply Revolve Cut. Open, it says open. It will automatically close this. Take the axis like this. You can see how the cut has been done. In one operation we did it. So you can either apply Revolve Cut or else apply these kind of extrusion cuts. So you have two options of getting the same result. So I will, any questions about that convert tool? You can roll forward and show this. So I will quickly recap the things I did. I will delete this and quickly do it again. Take the front plane, go to sketch mode. Better you make it perpendicular this way and get it hidden lines on. Then you can see inside nicely. Then draw a center line because this should be there to get the revolve. And I am using now these two convert entities. Convert entities will convert this 3D edge to a 2D sketch. This 3D edge to a 2D sketch. That's all I need. There's no boundary here. So I selected these two lines, edges, and make them two lines. Then we can draw the shape rough sketch. Now when I look at this is the result. So I didn't draw this trim. So I hope you understood. Now this is 75. This is 50. This is 37.5. This left is 20. That's all I need. It's a fully defined sketch. Now we can apply Revolve Cut. It's open. Just get this center line at the axis and 360 degrees. You can obtain that. So do this exercise and if you have any questions you can ask me after the break. So we will continue our lesson after the break. So you need to have this one and you can cut these holes. Those are not difficult. You can have a hole here and a mirror that one also and get the same shape. So we will continue the lesson after the break. We will meet at 11 o'clock.